And we're back. I know the suspense about the straw problem was killing you. Alright, so we are missing this angle right here. We just said they were a linear pair, right? So we know that they must sum to 180. So I'm going to take 180. There's no shame in my calculator game. I will do all problems like this just to make sure. So 180 minus 135 gives me 45. So I know this interior angle must be 45. Alright. Couldn't I say the same thing about these two angles right here to get this interior angle? It's sitting on a line, a linear pair with 110. So these two must add up to 180, right? So I know that this must be 70 because 70 and 110 add up to 180. And now I've got a 180 sum triangle problem. I've got two angles and a missing angle, right? So I can say that 70 plus 45 gives me 115, and 180 minus 115 will give me my missing angle, 65 degrees. So I'm going to say y equals 65 degrees. Alright, so we got all three measurements, and we walked you through how to explain how I got each one, right? Which is a precursor for proofs at the end of this packet. Alright, now this one's a little bit more difficult. So with this one, I'm trying to find x. I don't see really any way that I can get x from what I've got right now. What I actually need to do is extend one of the transversals into the parallel lines. Remember, we assumed that these horizontal lines are parallel because the problem told us. So I'm going to extend this transversal here. So I'm going to make this straw go out like this. Alright, I'm worried about it being perfect, and I definitely shouldn't worry about that. Alright, so if I've got these two parallel lines right here, and I've got a transversal that cuts between them, I know that 70 and this angle are same side interior, right? So if this is 70, I know this has to be 110 because they're same side interior. So now from here, I can figure out these angles and use it to solve for x. So if this is 140, this one must be 40, right? They have to add up to 180. They're sitting next to each other. They're a linear pair. If this is 110, then this has to be 70, right? Because these two angles sit next to each other. They're supplementary. So 40 plus 70 gives me 110. So I know that this angle, in order to, because of the triangle sum theorem, this one also has to be 70, right? Because all three of my angles, 40 plus 70 plus 70, should sum up to 180, which they do. So now at this point, I've got x and I've got 70 on a linear pair together, right? These two angles are supplementary. They must add up to 180. So I know that x must equal 110. So we extended that transversal out to finish solving that problem. Beautiful work. All right. And I meant your work at home, not my work. All right, so just a quick summary. We'll do this after every single triangle theorem. The very first triangle theorem, right? All interior angles of a triangle sum to 180 degrees. And we just solved a bunch of different problems using that rule and using some parallel line cut by a transversal angle relationship rules. All right, we're ready to go to our next page. We are flying through this. All right, theorem number 2. Again, you're going to be disappointed. This is actually something you already know. We're just putting a formal name to it. So base angles of isosceles triangles are congruent. We already know this, right? We know the base angles are opposite of the congruent sides. So base angles of isosceles triangles are congruent. We knew that isosceles have two equal angles, and those angles are the base angles. All right, converse. That's a word that we don't know other than with some shoes, right? Some kicks. All right, my husband just looked at me like, never say that again. All right, so what we're going to talk about right now is the converse of a theorem, which basically means if we go from A to B, we can also go from B to A. We're actually working backwards, right? So if we said base angles of isosceles triangles are congruent, we can say that the sides across from congruent base angles of an isosceles triangle are congruent. So this is kind of like a what came first, the chicken or the egg kind of thing. We can say that because our sides are congruent, the angles are congruent, or we can say because we know we have congruent angles, we must have congruent sides across from those angles. One leads to the other. It doesn't matter which one we have first. All right, example 8. Find the measure of the unknown angle. All right, so looking at this triangle, I have 116, and then I have the same variable for both angles. That means I have an isosceles triangle because these two angles are equal, right? So if I have an isosceles triangle, I can use that to figure out B. So I know that all three should sum up to 180, and I'm going to subtract 116. All right, so I know that B plus B should give me 64, right? So if B and B are equal and they add up to 64, how do I figure out what B is? I know B plus B equals 64, so 2B must equal 64. I can divide both sides by 2. So basically what I can do is take 64 divided by 2, and that gives me 32 degrees. So B is equal to 32 degrees. So now I can check myself before I wreck myself by adding up all three angles and seeing that they get to 180. All right. Now I want you to try the same thing on example 6. So I want you to pause the video and try example 6. We'll go over it in class. All right. And we're back for example 7. So for example 7 right now, let's make note of what you see on the triangle. So I see two congruent marks. So that means I have an isosceles triangle. And I also know that the base angles are angle A and angle C. How would I know that? Because they're directly across from the congruent sides. Alright, so that leads me to know what y is, right? If I have two congruent angles, I automatically know that y is equal to 52. Alright, so all I need to do is solve for x up here. And if I know that the base angles are 52, I can figure out that missing angle. So 52 plus 52 is going to give me 104. I'm going to subtract 104 from 180. And that gives me my missing angle of, oh my gosh, of 76. I don't know why I wrote 72. 76. So if this angle is 76, and this angle also equals 14x plus 6, I can just set 14x plus 6 equal to 76 and solve for x. Oh, the algebra is so fun. And I'm left with x equals 5. Alright, so I got y is equal to 52 degrees and x equals 5. Alright, I want you to go ahead and try example 8 on your own. We'll check that in class as well. Alright, and then let's move on to example 9. Alright, example 9. If the degree measures of angles triangle A, B, and C are represented by these following expressions, what type of triangle? Alright, so our different types of triangles are, what, equilateral, isosceles, scalene, and right. And so we know the degree measurements are represented by these. So the first thing I want you to do is draw a picture. Alright, A, B, C. Now our degree measurements, let's go in order. This would be A. So 10x is here. This would be B, x plus 42. And then C would be 74 minus 3x. Alright, so if I have all those interior angles, I know they should add up to 180, right? So let's go ahead and add them up. 10x plus x plus 42 plus 74 minus 3x. So this is angle A, this is angle B, this is angle C, and they should all sum up to 180. Alright, I have my like terms here. So 10 plus 1, because I know there's a 1 in front of the x when I can't see it, would be 11x. And then 11x minus 3 is going to give me 8x. Alright, now I've also got some constants here. I've got 42 plus 74. It's going to give me plus 116. Alright, I'm going to subtract 116 from both sides. And I get 8x equals 180 minus 116, which gives me 64. You know where this is going. If I divide both sides by 8, I get x equals 8. Alright, now we're tempted to stop here because we found x, right? But we cannot. We must plug it in because we're trying to figure out what type of triangle ABC is. So let's go ahead and plug it in. If I plug it in for the first expression, 10x, I get 10 times 8, which is 80 degrees. Alright, so that's my angle A. My angle A. My angle B is going to be 8 plus 42. And I'm getting these expressions right here. Alright, so 8 plus 42 gives me 50. And then my angle C is my last one, 74 minus 3 times 8. So we got 74 minus 24, which gives me 50 degrees. All right, looking at the three angles of my triangle, first let's make sure we did it right. We're going to add them up all together, and we should get 180, which we do. So I know I have two of the same angles, right? So I must have an isosceles triangle, and I'm sorry I didn't give you enough room. Isosceles triangle because I have two equal angles. Alright, I want you to try the same thing for example 10. You're pausing the video and you're doing example 10. Oh, and you're not done yet. Example 11 and example 12. You're doing those and you need to have them for class. So pause the video and get working on those. Alright, and we're back. Let's go ahead and summarize the two triangle theorems we've gone over, and I'm sorry it's nothing new yet, but number one, all interior angles of a triangle sum to 180, and then base angles of isosceles triangles are congruent. Alright, we're ready to move on to theorem number 3. Alright, so theorem number 3 is definitely something new. We haven't talked about it. So the triangle mid-segment theorem. So the segment joining the midpoints of two sides of a triangle is parallel to the third side and half the length. Alright, so knowing something is parallel is important, right? Because if I have parallel lines and they're cut by a transversal, I automatically have special angle relationships. Alright, and then the converse, right? The converse is if a line segment is parallel to the third side of a triangle and half the length, it is a mid-segment, which is a segment that connects two midpoints, right? A mid-segment.